welcome to my talk about Packer and Microsoft Azure. So I'm going to try and see if I can speed it up a little so we can make up for lost time. But I'll try and leave some room for questions at the end. If we don't get to that, then just find me on the conference. I'll be here the rest of the day and tomorrow, so it should be fine. I'm guessing like all of you know what Packer is. Raise your hand if you don't. Okay, I don't see any hands. Packer is the oldest tool, or one of the oldest tools, the second oldest in the HashiCorp family. And it's for creating consistent VM images. And Microsoft Azure, is that a thing that's sort of familiar with everybody? So Microsoft Azure is Microsoft's cloud, and we provide a whole bunch of services, but also VMs, just like everybody else. So we have a plugin for Packer to create images on our cloud. And that's what this talk is going to be about, so it's going to be sort of a show and tell. My name is Paul Meyer. I'm on the Azure Linux team. The Azure Linux team is basically trying to make Azure more Linux friendly, more accessible to users who are used to running stuff on Linux, and also like pushing stuff to Azure from Linux. And Packer fits exactly in that category. So the Packer Azure plugin is one of the things that we do. We also maintain the SDK for Go. We have a dedicated SDK team who maintains all of the SDKs for all the other languages, but Go was one of the newer languages, and they didn't have that yet, so we started it, and we still have that. Terraform also uses this SDK pretty intensively, and we have some other open source projects like Docker Machine. We contribute to that to make Docker one of the options, or to make Azure one of the options there. Our team, like the Azure Linux team, is pretty confident that Linux is very relevant to us, because if we look at our third-party IaaS images, so these are the images in our marketplace, then it's more than half that's actually Linux based, and the same with our community templates in our GitHub repositories. So looking at the market out there, I think that Linux is definitely something that we have to take into account if we want to grow Azure to the scale that some of our competitors are at. So a little history here. We started Azure somewhere in 2008 as a PaaS platform, mainly aimed at Windows. We've come a long way since then. We added IaaS, so infrastructure as a service, VMs. And in 2012, we started supporting Linux as one of the options there. And shortly after that, we started also developing these tools in our then subsidiary called MS OpenTech. So the initial Packer plugin was developed by MS OpenTech, similar to the Vagrant plugin, and there are some other plugins that you might know that we have there. But 2014 was a pivotal year for Microsoft because we changed CEOs, and with that we also changed a lot of our perspective on open source and Linux. And you might have seen the phrase Microsoft loves Linux on slides. I've also got it on my desktop background to remind me every day of how much we love Linux. But it's been a real change through the company on how we look at these things, and so it feels good to be in the team where I'm at right now. So we continued the Packer plugin from where OpenTech left it. MS OpenTech has now integrated back into Microsoft, so we now do the open source development from within the product groups. We introduced quite recently a new management API for all of our stuff in Azure called the Resource Management API, the Azure Resource Management API, also called the ARM API, if you abbreviate it. And with that, we also created a new Packer plugin for this API set, because it felt kind of weird to have two API sets in one, so we made a new one. And we contributed that back to HashiCorp in the official Packer repository. So now you get it out of the box instead of having to download a set of plugins. So why would we need Packer? Because, we're Microsoft, so everything with us is Linux, right? I mean Windows. See, we love Linux so much that I make mistakes like that. No, we have some internal services in Azure that also run on Linux. Good examples are HD Insight, which is our Hadoop offering. They offer a variant where you basically get your cluster on Linux. But we also have launched recently a container service where you basically can host your Docker images and stuff like that, or your Docker containers on our clusters. And that also runs on Linux. And there are some other examples as well that basically require Linux on the bottom. So to be compliant with all of our certifications, we need to have some sort of a secure base image with the right controls in place and logging and all that. So this is one of the other responsibilities that my team has, is to create these base images and keep them up to date. And so we looked around a little bit, like, what we use for that. We already had this Packer plugin, and almost the only other option would be to basically, glue it all together with bash scripts or whatever to provision these images and run commands on it. And Packer has just been awesome for this purpose. We need to do this in each of the regions separately because copying between regions does not have an SLA on it, so it can take an arbitrary amount of time, theoretically. So we need to do this in all of our regions separately, and currently I think we're in 30 regions, and so we build in all the regions where our dependent services run, so where this image is needed, and that's more than 20 at the moment, so it's quite a big thing for us, at least. So Packer uses the management APIs, as I said. So the old APIs were called the service management APIs, and the newer APIs are called the resource management APIs. The service management APIs are kind of service-oriented, so you basically, like the service is sort of the entity. The resource management APIs are way more granular, so a VM is its own entity, but also an image is its own entity, so a VM image, for example. And so all of these resources are now grouped more liberally in resource groups. And that's sort of the general model there. There are resource providers that basically provide a certain set of resources, certain types of resources, and that's sort of how we compose the whole API landscape here. So even for things like HD Insight, you would have a resource provider where you can basically do CRUD actions on your Hadoop cluster, that kind of stuff. There is also a sort of a lightweight template engine for orchestration. So you can compare this a little bit to things like CloudFront, or if you wouldn't have Terraform, you could use this. But this is also mainly to make our marketplace images work, because if you want a VM, you also want it accessible. So if you want a VM, you also want a network interface, and you also want a public IP. And so those are like three different resources that you want to deploy. And so it's easier to do that in one JSON document and say, hey, go and deploy this and figure out what you can do in parallel, than to do that separately. So the picture on the right shouldn't be, taken too literally. It's more of an illustration. But our cloud is very similar to other clouds in that, public IPs and VNets and stuff, they're all very similar. One of the main differentiators is that for our VMs, it's been historically so that all of your disks are always in blob storage. So you write something to disk and you can read it back through blob storage if you want, but they're always in blob storage. So also if you pick a standard image from our library or from a marketplace, basically you get a copy of that image in your storage account. And this is interesting to keep in mind when we get to the artifact that Packer produces. So to access all of these APIs, we maintain these SDKs for you. And so they're all open source. We developed this completely in the open, so all of our issues are on GitHub and all of our pull requests and comments are in there. And we have basically 3 top-level packages in there, which is ARM, service management, and storage. The latter 2 were handcrafted historically, and we also maintain them now handcrafted. So the APIs that you see in there, they're more human and maybe more opinionated in how they come across as a programmer. The ARM SDK we generate from the Swagger that the services or the resource providers themselves publish on GitHub as well. So these APIs, from a programmer perspective, can seem a little crude here and there. I'd love to get feedback if anybody uses this and has an opinion on what should be more hidden or what should be more discoverable, for example. That would help us a lot improving this. Currently, these are organized by resource provider, basically, and so each of the resources has a client that has sort of a CRUD function set on it. And each of these methods is basically composed out of a preparer, a sender, and a responder, where the preparer basically takes whatever parameters you have for this command and puts it in an HTTP request. The sender sends this HTTP request to the API and does polling if necessary. And then the responder basically takes the HTTP response and turns that back into a useful struct or maybe an error if there was any error. So when you start typing in your editor, you will see that all of these pop up. And usually you will want just the creator update here, but you might want to do the other ones just to verify that whatever you put in doesn't give you a different output, or you want to replace the sender, or it can be composed in a different way. And again, like any feedback on this is very welcome. So, all right. So let's switch a little bit towards our builder. Our ARM builder needs some information to get to basically start building your stuff and execute your provisioners on it. And it's not very different from other clouds. But let me go over them just to give you some background and get you started more quickly so you don't have to read all of the documentation, although it's just one page. But first I want to do like a shameless plugin for our trial. If you haven't used Azure, we offer a trial where you can basically spend $200 virtual on any of our services. And a Packer build is generally a couple of cents, so you can do a whole lot with that. And if you maybe have MSDN from your employer, then that's also an option because you can just flip on the MSDN benefits and you get also some virtual dollars per month that you can basically spend on playing with our builder. So that said, you need your subscription ID in the file because in Azure you can have more than one subscription per credential that you could do stuff to. And then there's the option of basically doing an interactive login at least once, and then it will refresh your token. So this will basically send you to a URL where you put in a code, and then you log in, and then Packer receives a token through some back channel. Or you can set up a service principal, which requires some more steps, and we're trying to make this easier together with the Azure Active Directory team. But currently, it's a little bit more cumbersome, and you basically have to put in a couple more GUIDs and a secret to make that work. But in that case, you would be fully automated, and you will never need any interaction from a user. So the second thing you will need is a source image. This can be a standard image, so from our gallery or marketplace. Or it can be a custom image, so you could also give it a URL to a virtual hard disk that you already have, so it's something that you would like to continue. So in our case, for example, we would bake an image, and HT Insight would say, oh, but we still need all this Hadoop stuff on there. So they would take our image and basically run some more provisioners on it to pull down some more packages, configure some stuff, and then save it again. So they have a new image that they built their clusters from. So that's an option. Currently, you can build either Windows or Linux images, either from Windows or Linux. It should both be, completely cross-platform, all of that. So you have to put in a VM size. You can always elect to go for the cheapest one, but if you want to build a little bit faster, you might want to pick a bigger one with more CPU, more memory, more bandwidth on the network, that kind of stuff. And lastly, you need to specify where to put the image once it's done. So there's like a storage account, which is in a resource group, because otherwise the APIs cannot find it. I'm thinking about maybe simplifying this and having it go through all of the resource groups that it has access to and trying to find it that way. So there might be a pull request for that pretty soon. There is a container, so this is basically sort of a path in the blob storage account and a prefix that you can give so that you can easily store more builds next to each other. And that's sort of it. And then so when you run that, which I did and captured the output because, demos never work, you basically get this kind of a view where you can clearly see the steps that the builder goes through. So that's basically why I wanted to show you this. So basically, it creates a resource group, and we use a template to deploy because now the template engine will basically decide what can be done in parallel, and we don't have to code all that by ourselves. We just give it a template and then pull until the template is ready. And then when it's deployed, we get the public IP address, hook SSH up, and we can start provisioning, right? And so when it's done provisioning, we basically query the virtual machine because it will leave hanging around the OS disk, because although it captures the image, the OS disk is also in the same storage account initially. So we need to clean it up manually at the end. So we'll get that information. We'll power off the machine, capture your image, and basically delete the resource group and the temporary OS disk. And then what you get left with are these I highlighted in red and blue. So in red is basically the disk, and in blue is the template. And so the template is just a little JSON snippet that will allow you to easily redeploy your VM. And so we don't only give you like the URLs into blob storage, but we also generate, for your convenience, a SAS URI. This is a URI that's basically publicly accessible for a limited amount of time. So in this case, it's 30 days, I believe. And it's read-only, so you can use this to easily glue stuff together. So if you take a look at what the template looks like, got it open here. I'll move it to the other screen. Over here. So as you can see, there are some parameters for things like VM name and VM size and that kind of stuff. And it will let you hook up to a network interface that already exists. And that's basically what it does. It has only one resource in it, which is the VM, so it's very constrained to that. But you could use this and take another deployment and just point to this as one of the sub-deployments in there. Basically give it the parameters that it needs. So you can see it plugged in the image URI here that was visible on the other screen as well. It's not magic. I just wanted to show what our JSON looks like. All right, so let's get back to our presentation here. So what I wanted to do now is to jump into the code of the builder and not walk through every line, but just show you an outline of what a builder looks like. And this is in case you might want to do a builder yourself. It doesn't need to be for Azure, but creating a builder is not too much work, actually. I heard some people who did providers for Terraform, and this is, I think, very similar in a lot of respects. So I think it's helpful for people to be able to read this code easily and help us fix bugs and stuff like that, and not just in our provider, but just in Packer in general. So the general outline of a builder is basically there's a prepare method. So at the bottom here, you see basically the methods that are in the interface. So there's a prepare method, which basically gets in all of the configuration values as raw interfaces. And so there are some convenience methods to parse that into some structure that you already have, which describes your configuration. And this is all very standard stuff, and if you look in all the builders in the Packer repository, you will see very similar patterns. So I'm not going to show exactly that. Basically, it reads your config, it validates that all of the necessary things are set. If not, it will give back a bunch of errors, which Packer will show on the screen and say, hey, you missed something. If everything is good, Packer will run your run method. And as you see here, it will give you a UI object or UI struct, a hook, and a cache. So to start with the latest, the cache is basically some, you can put stuff in there that you might need if you have multiple builders or if you want to store something temporarily. It's basically artifacts that you want to throw away at the end. So you can put those in there. The hook is basically required to be able to start provisioners from your builder, and the UI is basically a struct with some methods to be able to communicate stuff to the user. Because the way that Packer runs your plugin is as a separate process. So there's a separate process in which your plugin runs, and everything that comes to standard out and standard error is basically considered debug logging. So if you're not looking at the debug logging, nobody will see that. So if you just do like a fun printf, nobody will see that, except the people looking at the debug logging. So you will have to use this UI object and its methods to say things to the user. In the run method, you basically create a bunch of steps. This uses the multi-step package that's in under Mitchell's GitHub account as well. And basically use a runner to run through all of these steps. And so these steps are basically aligned with the steps that you just saw in the output. We'll see this in the code. And then so when it's done running those steps, you basically craft an artifact. So in our case, we already have 2 pieces of information. Then we craft those SAS, those shared access signature URLs as well. So we do that at the end. And that's basically it. It's pretty simple, right? So let's take a look at what that would look like in code. So let me see if this is the most exciting moment of all. It's when we switch. All right, so this is, you can read it here at the top. This is in the Packer tree. This is our builder.go. And so you see the 3 methods that are in the interface. By the way, I didn't talk about the cancel method, but the cancel method is called when the user wants to cancel. So it seems kind of obvious, self-explanatory. So in the prepare function, this is all pretty standard. So we've hidden some of the standard calls and all of the, so providing default values and doing validations in this new config method. But basically, you then persist your config on your builder so that you can use it in your run method. And that's sort of it. So when we take a look at the run method, there's some ceremony here at the beginning, some dumping the configuration for logging, that kind of stuff. So after that, we do our authentication. So this is where we do either the service principal dance or the interactive login dance and get the token back basically for accessing the APIs. And then we build our client. So we basically compose a bunch of clients into one. So if you look at this Azure client, it's basically a blob storage client, a deployments client, a groups client for creating and deleting resource groups. And so we compose them all together so we only have one client to pass around. This is just for our convenience. We like this pattern. I'd love your feedback on this. So we basically create that, and then we set for each of these the token in the authorizer and we hook up some inspectors to be able to show the complete REST request in the output, in the debug output, and that's basically all it does here. So I'm not going to spend too much time on that. So let's skip these couple of lines here. So and then we get to the sort of the body of the run method, which is setting up the steps that are necessary to do whatever you need to do to build this image. So we basically have two variants of this. So we have one for Linux and one for Windows. So let's take a look at the Linux one just because it's on top. So you can see how these line up with the stuff that you just saw in the output where it says, you know, creating resource group, validating template, deploying template, and stuff like that. What you also see is that things like connecting SSH and doing the actual provisioning are things that the Packer has already built in common places. So it's easy to just use that instead of trying to create your own. I don't think there's a good reason to do that anyway. So let me dive into one of these methods to sort of show you what they look like. So these are basically sort of factory methods for creating these steps. So in our case, for a step, we chose to have it basically be a struct where we have some fields that are mainly funcs. And the reason that we did that was to make this step testable in a way where we don't need to go out and call the API, because it takes long and it's error prone, because if there's something that doesn't go right exactly, then your tests fail, and it's not because of your code, so you don't want that. So what we basically have is that you have this create method in this case, because this is creating a resource group, and the create method is basically the call to the API. So if you look down here, it says this create method, hook that up to the create resource group. And this is just the API call. It's nothing more. The only thing it does is drop the output, because we already put in the name, and if it doesn't give an error, then it should be okay. And so the run method for this step, because each step has a run method and a cleanup method, which is called in reverse order after all the steps are done. But the run method basically should just do whatever the step does. And so in here, we call this create method. So if we go and look at our tests, for this, then you will see that that these tests usually stub out the create method with something that either fails the call to the API, and then we test that the right things are set in the run method of the step, or it might succeed, and in that case there should also be stuff set in the state bag. It shouldn't throw an error, and so on. So that's sort of how we did that, and also why we did that. All right, so let me jump back here. So then, after we created all these steps, there are, again, some standard things to do, some standard ways to run all of these steps, and they basically involve the multi-step package. You just create a runner and basically run it, and it will leave errors in the state bag if something went wrong. So after it ran, we basically check whether one of these things happened, and if it doesn't, we basically get the information that we need from the state bag and create the artifact that we want to return to Packer for doing post-processing and displaying. And that's sort of it. And there was one thing that I still wanted to show, which was basically because we are doing this deployment, we're generating a bunch of JSON. So one of the neat things that we did here is that we have this, let me open the test file for that. So we have this way to basically say, okay, so I'm generating a bunch of JSON. I know what it looks like, right? So I can verify basically against that. So we have this approvals package where we can basically say, verify this reader to against whatever I know this test method needs to yield. So what this verify method does is basically look up a file which is named very similarly to the test method. So in this case, it's test virtual machine deployment 3. And so it basically looks at this JSON and verifies that whatever the reader has in it is basically this. And that's sort of neat because it's easier to update than having all of these blobs of JSON in your code and stuff like that. So that's what I wanted to show about the code. I hope that wasn't too much. So let me go back to this presentation here. There we go. You're a geek, you want a background, that's what you do. All right, so in terms of feature requests that we've heard Truth Builder a couple of times, so we're pretty much committed to doing that as one of the next things. Another thing that we have heard is that it's undesirable to have your service principal require owner permission on your account because you need to create a resource group. Now there have been some developments in the ways you can constrain permissions in Azure, so we'll see what we can do there because we either add some policies or something like that. We're figuring this out. So we want to fine-tune it so you don't need to give ownership permissions to this service principal. And then there's some small stuff, some improvements in terms of what you need for configuration. But that's about it. I would gladly invite all of you to give us feature requests because we do want this to be a very good way of accessing Azure and building images. And so, as my last slide for the recording as well, I put some references up. So the top one you all know, but the second one is our old repository where basically the service management plugin lives. We still use that internally because not all of our services have switched to using the resource management APIs. I put my email address on there. I also put Chris's email address on there. Chris is my colleague who has done a lot of the ARM builder work while I was busy doing other stuff. And so we're both very open to feedback on that. There's a nice talk by Mitchell on Packer plugin architecture on YouTube. And I'm not sure if I don't think you can get that URL, but if you want to just email me, I'll send it out. Something for Azure trial, and there's a nice tool for if you want to debug your resources. You can go to this resources URL, and it basically shows you whatever resources you have, and the REST API is on the right. And so with that, I thank you very much for coming to my talk. And if you have any questions, come find me. I don't want to take any more time out of the schedule because we started late. All right, thank you very much.